Hello and welcome to Autoflight System for the Airbus A320 family. We are now getting into the heart of the flight of the aircraft, so performance of the aircraft. And it's going to be through the use of computers. So we are back to computers. However, this is specifically referring to the flight, the inputs regarding the flight and performance of the aircraft. Basically, the Autoflight system is responsible for calculating the orders in order to control the engines, the fly-by-wire, your navigation, flight controls, flight plans. And there's 4 computers in this Autoflight system, which is abbreviated AFS. Just in case you see AFS, that does stand for Autoflight System. There are 4 computers. Okay, there's 2 FACs, okay, which stands for Flight Augmentation Computer, and there's 2 FMGCs, which stands for Flight Management and Guidance Computers. So those are what you have: 4 computers, 2 each, 2 Flight Augmentation Computers and 2 Flight Management and Guidance Computers. Okay, so in a nutshell, you know, what is its function? What is it controlling? There's 2 parts to this. You have the management part and the monitoring part, and it's just constantly getting the inputs in order to, give the orders for the control of flight control surfaces and also for engines, because when we get to power plant, we'll be talking more about FADEC, but that is basically your control brains for the engines. Okay, so here, we're talking about what is it controlling in order to have a great performance or optimal performance of the flight of the aircraft, including being able to, have the input of a certain flight plan, and then dealing with all the variables in between, from the point of origin to the point of destination. So we have the fly-by-wire, the flight plans, the navigations, the operations here, but we're also, what is it actually involving? It's involving controlling of the yaw. So remember, if you remember from flight controls, there's different aspects or behavior of the aircraft. And so, we talk about the lateral control, right, longitudinal control, and we have these different aspects to it. This is all having to do with how the Autoflight system is going to be needing to perform. So, just to kind of reiterate, we do have the 2 computers each, for FAC and for the FMGC. All right, and we have this system that is sending data. It's receiving data too, but it's also sending out data to other computers that are in charge specifically for certain operations. So for example, flight controls, that's one operation. It's going to be sending data to the electrical flight control system, the EFCS. Okay, well, we're talking about engines, because it also can run that automatically and monitor that. It's going to be sending data to the FADEC. Okay, that's your Full Authority Digital Engine Control. And it's doing all that, where it's kind of orchestrating all of this to control both the engines and the flight control surfaces. Okay, so that's one way. That's what it's doing. Okay, now if we don't have an Autoflight system, because it can be either engaged or not engaged, 2 choices. Okay, if it's engaged, then it does everything I just said. If it's not engaged, then we have the other option where we still have control over what I just mentioned, but it's a different way. This time it's through side sticks and thrust levers. So we have that going on. And just kind of a side note, if the Autoflight system is engaged, then you're not going to have an actual automatic movement, okay, of the side sticks and thrust levers. It might seem like, oh yeah, it's going to move, but it does not. So you may want to table that one somewhere in your notes, but that is just something I wanted to throw out there. You might see that on a test. Okay, so I also mentioned about navigation. The Autoflight system is getting data from the aiders and being able to take that and calculate the aircraft position through that. So it's going to, obviously there's aircraft sensors throughout, so it's going to be utilizing all of that. So basically it's trying to be very efficient with what operations need to come into play between point A and point B in a nutshell. Okay. Okay. Now, besides the 4 computers that I mentioned right from the beginning, we also have 2 MICDUs. So we have our multi-purpose control and display units, and we also have 1 flight control unit. Okay, so 2 MICDUs and 1 flight control unit. And just a quick note, the 1 flight control unit is your short-term interface between the crew and the other computer that I'm going to cover, which is your FMGC, which are your flight management and guidance computers. That's kind of the flight control unit is your short-term interface. Okay, your MICDUs are your long-term interface between crew and the FMGCs. So just a distinction between those two and how they're going to be performing or working is one is short-term, one is long-term. Okay, so and with the flight management and guidance computers, because you have your flight augmentation computers, and I'll get a little more detail in a bit, but you have your FMGCs. Okay, those have a management part and a guidance part. Okay, so there's 2 parts to that. Management is important, being able to manage the information for having the flight, based on flight path, etc., and being able to perform at optimal levels. Okay, so most of the, most of the other systems are actually connected to the AFS, in order to have an auto situation. And some of the controls that you have here, so let's, kind of address the flight control unit. The flight control unit is installed on the glare shield, and by the way, the computers obviously are in the avionics bay. Okay, so that's going to be on the test. By the way, you should know where things are. So those are located in the avionics bay, on the right hand side. Okay, and remember you have 2 of those there. So all right, so back to what we're saying here with the control unit. You do have that on the glare shield. Okay, and you've got a control panel as well. That's between the 2 EFIS, your electric flight information system control panels. So that's where that's located. And then you also have, there's the electronic flight instrument, which is the EFIS is your electronic flight instrument system, in which the AFS control panel is between those 2. And then of course you have your MICDUs. Your MICDUs are on the center pedestal, so you'll find those there. Okay, those are just controlling the flight, the parameters and flight plans there that can be put in there. Okay, you also have 2 navigation displays. Those are on the main instrument panel. So MICDUs are on the center pedestal. Navigation displays are on the main instrument panel. And the other thing that you find on the main instrument panel is the primary functional displays. There's 2 of those. So you got primary functional displays and navigational displays on that same main instrument panel. But the MICDUs, your multi-purpose control and displays, are located on the center pedestal. Okay, so you also have a flight mode annunciator. That's part of the PFD, which is the primary functional display, like I just mentioned. It's just short PFD. That actually, the flight mode annunciator is the top part of that. Okay, and what is that for? It's going to be, showing autopilot, auto throttle engagement status, things like that. The other thing too that's kind of a characteristic of the annunciator is also showing the characteristic speeds on the speed scale. There's a speed scale as well, but the types of information you're going to find on here, again, like I said, related to auto throttle, your autopilot, flight director mode and status, and flight management messages will be on there. Okay, so, and of course it helps to just kind of get an idea, get familiarity with your eyes on what these panels look like in the Airbus. Aircraft are very similar, but there's uniqueness to it, which is why you're taking this Gen Fam. But the flight control unit, you can get a kind of an orientation with the layout of it and see what, where these push buttons are. These push button switches are located there in relation to one another. It gives you an idea here. You've got one for captain as far as your electronic flight instrument system control panel. You got one for captain and one for first officers. So it's just a mirror image there. Okay, and then of course you got your MCDOs on your center pedestal. Okay, so you've got those readouts, and that also just incidentally is where you're going to be doing your system testing. So you got your system report / testing. That's where you hit that and run some warning tests for the Autoflight system. Okay, that's a side note. All right, so on AFS control and indication, you have different columns. There's 5 of them. So you've got columns for your lateral modes, your vertical modes of the aircraft, and you got auto thrust operation as well as your approach capabilities. Okay, for most important aspects or phases of flight is going to be your takeoffs and landings. So with here, column 4 is going to be showing approach capabilities, and 5 is going to be your engagement. When does the auto throttle engage? Okay, there's certain parameters in which that happens, but that's where it would be displayed. That's where you would actually see that, is in column 5, okay, for your autopilot, your auto throttle engagement. And then of course any other types of messages, you got, like common modes or any special messages are going to be in columns 2 and 3. I mentioned 2 and 3 columns are going to show your vertical and your lateral modes respectively. Okay. And then so each of these columns has 3 lines to them. The first line is going to give active modes, line 2 is going to give armed modes, and then line 3 is going to give messages. Okay, so line 1 gives active modes, line 2 gives armed modes, and then line 3 gives messages and others messages. And it depends on which columns as to what line, like if the line 2 shows up, it's going to be in certain columns. But just so you're aware of the idea of the lines. Okay. Okay, and then there's different colors. We talk about color schemes, and we've been talking about this, and amber means caution. So when there's a fault detected, as long as it's not one of the faults, there's some faults that you can still have it's like a sub fault, if you will, that can exist, but the fault button, or I should say, the fault button won't be illuminated, and there won't be like the amber color showing up on the ECAM display. But that's like a very small thing. But here we're talking about the typical colors that you might find on the of the messages that'll show up will be red, amber, or white. Okay, obviously amber is caution, red is, hey, this is very important. White, it's just letting you know that something's here. So it just, the priority is with red, obviously meaning, hey, there's something really needs your attention right now. Amber obviously is not so bad. This is your second priority. Typically is your vertical flight management messages, and then your white you'll have some flight instrument reconfiguration messages, but those will be in white. So they also can flash, so besides just kind of staying put, you can also see the flashing in white color or in an amber color. And so obviously if you have a master caution light that flashes, you're going to typically have that sound come on, and that's going to be going on every so many seconds. And it'll just continue until somebody does something, about it to clear it. And then you also have blue. Blue is for your speed related, presets that you have there. And so just kind of be aware of color. Blue has to do with speed. Okay. So remember I said that column 4 is your approach capabilities. You've got, different categories for landing. And that line 1, okay, because line 1 was for your active mode. Remember I said that, kind of associated with vertical, but line 1 is your text that relates to landing category. So you got your Cat 1, Cat 2, or Cat 3. That's always going to be a white. Okay, now just always check with your AMM, but that's, I'm just going to say typically white. The other one's going to be your operational. So line 1 is landing category. Your line 2 text is going to be pertaining to the operational status of that particular landing category. Okay, so, you know, just kind of giving you a rundown of that. The other thing too I wanted to mention, because there's, you know, here there's a line 2 text that would just be a single line that would be fail passive. If there's 2, then it's a fail operational. The difference between those two, and I didn't mention this before, but I'll mention it now. There's 2 aspects to, you know, the whole thing with this is you have a fail operative. Your auto flight system is a fail operative system. What do I mean by that? Okay, so what I mean by that is fail operative just means that if there's a failure, okay, if there's an indication of something wrong, there's a fault, then the plane is automatically going to do something. It's going to take some action to ensure the success of an ILS approach, you know, and a rollout just immediately after the failure. You know, so that's what the fail operative means. It's going to take some. It already has like a program, you know, that if this then that. So that's what that is. Fail passive will show what's wrong. It'll show up on displays that, you know, something's not right, but it's not going to be doing anything. Okay, so just wanted to address that. All right, so it's kind of some ideas with the controls, your indications that you have. In column 5, column 4 was approach capabilities, so you know that has to do with the landing. Your column 5 is engagement status for your auto throttle, okay, your autopilot. So you've got that, as well as your flight director. So that column 5 has to do with that kind of information, and that can show up in a white color when it's active. Blue is typically, that means when it's armed. If it's armed, it's in blue. Okay, otherwise if it's engaged, it's in white. Okay. And of course you do have indications for your thrust levers or control. For your thrust levers, your rudder pedals, your side sticks. And so with rudder pedals, those obviously are where you find rudder pedals on the captain and first officer positions. That's one way that you can have a disconnect of the AP. Okay, so once you have the rudder pedals override engaged, then that's going to disconnect the autopilot. The thrust levers, those are located right on the center pedestal, and those are used to engage the toga modes and your auto throttle as well. Of course, you have your side sticks, okay, one for each, you know, for captain and first officers. And so, you know, if you have the push button, you know, on the side stick, that's for, you know, press down, or you just have a force on that stick, then it's going to disengage that autopilot. Okay. The other thing that you may or may not have been exposed to, because if you're familiar with Boeing, whether it's next gen or whatever series on the next gen, here in this particular case, we have what's called attention getters. These are things that pretty much are right in front of the pilots, and just kind of a quick, almost like a quick reference guide, if you will. I wouldn't call it a guide, but it's just like it, because these are right there on the glare shield, okay, on each side. So right in front of the captain, right in front of the first officer. And so let's just say that you have a master caution, or you have the master warning lights that are on. Those are activated when you have a disconnect of the auto flight system. Okay, and so these are going to be showing there, and you have the auto land as well. You have an auto land warning that's activated when there's something wrong during that final approach. Because that's the other thing. Remember, I said this is a fail operative AFS. This is a fail operative auto flight system. So when something happens, then the next is having the operation of the ILS approach and auto land. You know, so that's part of that. Okay, so you have that. Just remember where that's located. Where are the attention getters located? They're located on the glare shield panel. Okay, for each captain and first officer. Okay, you also have the EWD-SD. You got your engine warning display, system display. Those are on the main instrument panel. Obviously, you have warning messages that that will be there. You'll also have information, AFS information on status, okay, or landing capabilities, availability. What's going to be available or not. That's a system issue, and that will be showing up on that system display. Okay, all that whole thing. You also have what's called the radio management panel. That is on the center pedestal near the two MICDUs, and those are used for the nav aid standby selection. Okay, so radio, obviously radio signals or waves has to do with our navigation aspect to our flight. Okay, so just kind of giving you just kind of a recap before I start talking about some of the kind of aspects to the computers. But you've got, the whole idea with Autoflight system is being able to control and to monitor the different components that are affecting the performance of the aircraft itself. Okay, so the flight of it. And so we're going to be coming across some threats. I say threats, we're talking about wind shear detection, flight envelope protection. When we talk about the rudder, I talk about rudder control, or I should say rudder trim control, and your travel limitation on that. All that is needing to be monitored and manipulated, and the Autoflight system is going to be participating with all of that, including the yaw damper, because you don't want to have the Dutch roll go on. So it's going to be helping with all of that to maximize the performance of the aircraft to get from point A to point B. Okay. So I hope that gives you a fairly good idea. Of course, seeing the displays and what it looks like from the pictures, that always helps to give you an idea of your Cat 3. What is, where is that on the actual display? What does it look like? You got your speed, your GS, you got, and you got that listed on there for, for your category, or whether, and then remember I said single or dual, so it'll say dual or single, whatever. Okay. All right, and of course your MICDUs, where are they located? Those are on the center pedestal. You got your flight mode annunciator. Okay. And incidentally, what controls the flight mode annunciator? Okay, that's going to be your FMGCs. Okay, actually, in particular, you got two FMGCs, but there's one master one, because remember, this is redundant systems, why we have two, but there is going to be one as the main one. That's going to be supplying both the FMAs, both the flight mode annunciators. Okay. And so your FMGCs are going to be displaying that auto throttle information. So that's the connection, if you will, between the flight mode annunciator and the FMGCs. Okay. All right. So let's just kind of get into some knowledge checks a little bit, and then we'll proceed with session 2. All right. So, question. What's on the top of the PFD? Okay, PFD stands for primary functional display. What's on the top of that? Okay, option A, is it flight mode annunciator or navigation annunciator? Okay, that's going to be the flight mode annunciator. That's located at the top. What are the functions of the automatic flight system? Okay, or autoflight system. Okay, you got option A. Is it to calculate orders to automatically control the flight controls only? Or to calculate orders to automatically control the flight controls, engines, and aircraft position? Okay, it's the latter, right? It's all that. During AFS operation, autoflight system operation, the side sticks and thrust levers move automatically. Is that true or false? That's false. Remember, I was stressing that. They do not move automatically. Okay, how many flight management and guidance computers are there in the AFS? Is it 2 or 3? Okay, there's 2. Remember I said there's 2. How many flight management and guidance computers, how many flight augmentation computers are there in the AFS? 2 or 3? Okay, that's 2 as well. It's 2 of each. How many FCUs are there in the AFS? Okay, your FCU is your flight control unit. How many of those are there? Is it 1 or 2? It's 1. And by the way, those are, you know, we'll go into a little bit more of that. Okay, next one. How many MICDUs are there in the AFS? 1 or 2? Okay, there's 2 of those. All right, which component is used for short-term control of the aircraft? Okay, remember I said about short-term interface. Okay, is it your MICDUs or the FCU? Okay, short-term is FCU. Which component is used for long-term control of the aircraft? Is it your MICDUs or your FCU? That's an easy one. That's a gimme. I just gave it to you. Okay, obviously it's the first one. It's MICDUs. It's not the second one. Okay, which component does the interface between the crew and the FMGC to allow for management of the flight? Okay, that's you know, we basically went over that. That allows for management of the flight is going to be your flight control unit. Okay, so think about management and control because they go together. So which component does the interface between crew and the FMGC allow for management of the flight? That's going to be your FCU. Which component does the interface that's necessary for transfer of engine data from the FMGC to the FADEC? Okay, which interface or which component does that interface? Okay, that's going to be your MICDUs. Allows that connection between your FMGCs and the FADEC. FADEC has to do with your engines. All right, which computer is responsible for the protection of the flight envelope and the rudder control? Okay, is it the FAC or the FMGC? Okay, it's going to be the flight augmentation computer. So remember, anything having to do with we'll get into management and guidance, and of course our next session is going to be on the actual augmentation computer. But there are different things that it does to protect, and in this case, the FAC is responsible. Okay, your flight augmentation computer is responsible for the protection of that flight envelope and also for rudder control. Okay, which computer is responsible for the flight plan and control? Is it the FAC or the FMGC? Okay, so flight plan is different. This has to do with the FMGC, the flight management and guidance computer. All right, regarding the controls and the indications, name one indication that you might find on the FMA. Okay, on your flight mode annunciator. Okay, that's going to be your auto throttle mode status. Okay, flight plan data, that's not, it's auto throttle mode status. All right. Okay, where are the MICDUs located? Is it on the main instrument panel or on the center pedestal? Okay, I think you guys, it's on the center pedestal, right? Okay, what are the two parts to the FMGC? Is it the flight management part and guidance part, or the flight management part and main control part? Okay, I mentioned that before. It's the flight management part and the guidance part, right? I mean, the name just makes it obvious. All right, so what can you find on the main instrument panel? Two PFDs or 2 MICDUs? That's an easy one since we just know what it was on the other one. All right, so it's going to be your PFDs. because we know MICDs are on the center pedestal. All right, so where's the FCU installed? Is it the center pedestal or the glare shield? Okay, remember I was describing how it's right in front of the captain or the first officer, well, each of those. You have the glare shield, and that's where the FCU is located. Okay, all right, so I'm gonna just kind of pick and choose because there's a lot of ones that we can go over, but let's see. Well, let's talk about, let's kind of do it one more question and then we'll call it. All right, so the auto land warning. I know I mentioned auto land very briefly, but the auto land warning, there's an auto land warning that displays on the main instrument panel. I don't know, is that true or false? Okay, it's actually false. That auto land warning is actually displays on the attention getter panel, which is on the glare shield panel. So that's where you'll see that. Okay, how many columns does the FMA have? Okay, I mentioned that before. It has 5. Okay, your choices are 4 or 5. The answer is 5. Okay. All right. So I hope that gives you kind of a rundown of what we have with the Autoflight system. Okay, and then we'll just go ahead and get into our next session, which will be on the flight augmentation computer. We are now on to session 2 on the Autoflight system for the Airbus A320 family. All right, so our last session was kind of an overview of the Autoflight system and what its function is. Basically calculating orders for flight control, being able to also, interface with engines in order to just have a higher performance of aircraft as you have an input of flight plans from the pilot. And being able to get from point A to point B with different variables. So with here, we're talking about the flight augmentation computer. There are 2 computers, 2 flight augmentation computers, okay? Like just kind of reiterating from first session. But what are the functions of the flight augmentation computer? Well, it's going to be affecting the the yaw damper, rudder trim, as well as your rudder travel limitation, and also your flight envelope protection. Okay, so those are the different aspects to the performance of the aircraft that's necessary, again, to have the best and safest, performance. So this is where this computer comes into play. Just kind of want to start with flight envelope protection, actually. Your flight envelope, the different variables that we're talking about here that could become a threat if it's not within a certain threshold is your angle of attack. Okay, especially that changes, and of course then we may be affecting pitch control, so that may come into play. But this is all having to do with, not just in the flight, most importantly in landing. Okay, so here it's going to be dealing with speed. Speed obviously is an important element here, and so the FAC is going to be computing different speeds for the operation of that aircraft. It's going to be giving a low energy warning. Just we talk about other systems and how how pressure and temperature are very important, in those closed systems. Here, when we talk about aircraft energy, we want to have enough aircraft energy. All right, we don't want to have something too low, and this has to do with the speed. It also has to do with acceleration rate as well. That's part of it. Your speed is one thing, but then in a certain direction, that's when you have velocity. And of course, now we've got acceleration in relation to those 2 variables. So, if it goes below a certain energy, then there's going to be a warning that's going to be sent to the ECAM. Your excessive angle of attack, okay, that's what's called an alpha floor, just to let you know right now. But you're going to hear that later on. But I might as well just get it in your head a little bit right now that's what an alpha floor is that there's too much angle of attack. That's what we don't want. Okay, you also have wind shear, and that wind shear, just kind of in case you don't know, or maybe you just need a refresher, but wind shear is a condition in the atmosphere where you have kind of a clashing, if you will, of wind from different directions, like usually from 2 opposite directions or 90-degree angle or whatever. And so when that happens, it's creating you know, it creates a force that works against the aircraft when it's in flight, and that can be, you know, just be not a good, you know, a good atmospheric condition for the airplane. It's going to have to work hard. It's going to figure something out to maneuver around that. So there has to be a detection of those wind shears, you know, and so this is what we have, you know, with the augmentation computer being able to gather information from different sensors, etc., from the ADARUs in order to, you know, to give those warnings. Okay, so there's that. You also have the interface. So the computer, I mean the FAC, okay, your augmentation computer is going to also get information from the landing gear control interface unit. So that's from your LGCIU, also from the FMGC, okay, from the flight management and guidance computer, which I'm going to talk about in the last session. It's going to get data from there as well, and also from your SFCC, where SFCC is your flap control computers. And so there's two of them. You know, your SFCC1 and then the other one SFCC2. So those are going to come into play later when we talk about conditions and what happens if. Okay, if this, then that. These are going to be displayed. So this kind of information is going to be displayed on the primary functional displays. Okay, so all this information is going to be sent. Okay, so FAC computes it, and then it sends it. It computes it, and then it sends it to the FMGCs. Okay, so even though it is using data from the FMGCs, it's still sending, you know, computed data based on the other information it's getting, and still sending it to the FMGCs. You have a low energy warning computation that's sent to the flight warning computers. And so you've got an oral warning that's actually speed, speed, speed. Okay, that's what's being heard, speed, speed, speed. That's what you have for low energy. The rudder trim, those are coming from a RUD trim selector, or it can come from the FMGC to control the rudder. Okay, obviously through the actuator. So you've got rudder trim. That's a big part of being able to have, you know, performance that's necessary. The yaw damper is going to help with, you know, not having that Dutch roll. So it's going to inhibit that potential, that Dutch roll. It also is going to compensate for engine failure in autoflight. So the yaw damper helps with that. That's one of its functions, is to control the rudder through the actuators of the yaw damper. Okay, and then you also have the controls of your trim reset, and so you know, with those you got inputs that are coming from those push button switches into the flight augmentation computer. Okay, and of course the reset buttons are going back to original position, right? Okay, so just an example of one thing that you'll see as far as after the FAC has computed something. It's going to be characteristic speeds. Okay, those are on a speed scale, and those are going to be displayed on the primary functional displays. The other thing that you will see is an indication for the wind shear. Okay, that's going to be showing up in a red color, and that'll be in the center of both those PFDs. Okay, the other thing is the rudder trim position. That'll also show up on the ECAM page. That'll be on the flight control ECAM page, and also on your rudder trim control panel. Okay, and about location. Okay, obviously it's in the avionics. These are in the avionics compartment, but it's on the right hand side. So question, is it on the left hand or the right hand side? It's going to be on the right hand. It's the aft avionics bay, not the front. So it's in the back, it's right hand side, and that's where you'll find those computers. Okay, and just so you know, they're on the ADVU section. All right, so let's talk a little bit about, you know, I mentioned yaw damper and how, you know, right, the FAC is getting involved with, you know, with these different things. Let's just suppose that we have a normal configuration. Okay, so a normal configuration, when you have the FAC push button pressed in, then you're not going to, it's normal configuration. You're not going to have the fault and off lights on. They're going to be off. Okay. And so everything's good. If you have the FAC push button released out, the FAC is disengaged, and then you're going to have that white off light. It's going to show up. Okay, just a kind of a note here. The FAC, like when you're after a power up, which is your 30-second test, it's kind of like rebooting, or excuse me, like booting up. The FAC cannot be engaged during that time. It's just like booting up your computer. How many things can you start doing, start operating? Well, you gotta wait till it warms up. So there's a power up test it's got to go through with the aircraft, and then you're able to engage that FAC. So you have that. Now, as far as your yaw, and this is for access control, your yaw access control functions, if you have one of those fail, there's only an amber message that's gonna show up on the ECAM. So here's one example. Remember I said in session 1, just because you have a fault doesn't necessarily mean that the fault light's gonna come on. And this is one instance where you have what's called a subfunction. So it's a fault, but it's a subfunctional fault. And so it's an example if you only have the one, failure, that the amber message will show up on the ECAM, but the fault light's not going to come on. Now, the time that the fault will come on, okay, so this is a big deal. The time that you will have the fault light come on is if you have temporary power loss. So if that happens, then you will have that fault, the fault word there on the push button, that's actually going to light up. And then you're going to have a message on the ECAM, obviously, for that. And also, as far as reset, because temporary means temporary, it means you may have temporary power loss, but you're going to get it back. Well, when that comes back, is it possible to reset? Is it possible to reset? You reset it. You reset the FAC. And yes, you can. You're just going to use the FAC button to reset it. Now, there's 2 yaw dampers, and so in normal operation, those are engaged. Okay, but you're going to have one that's active. So there's a difference between being engaged, but one is actually active. Your first one, your yaw damper 1, is the one that's the main one, and that as far as being able to operate is going to be involving different components. Okay, it's going to be obviously involving the flight augmentation computers, but you also have rotary variable differential transducers. You have 2 of those. You also have your actuator that has different components associated with that, your servo valves. You have a pressure switch, that kind of thing. And then you also have 2 electrohydraulic actuators. Okay, so these, I'll go to what I just said about the actuators. Those are the different subcomponents that they have with them as your valves, and of course the transformer, or excuse me, transducer. You get linear variable on that one. So I just kind of give you an idea of the yaw damper function, And so what do we have in relation to this here? Basically, when you have both dampers engaged, then the first one, okay, channel 1 is going to be your yaw damper 1 is going to be the main one. That's going to be running first, or active, if you will. And so then the second one is going to be kind of synchronized on the position of that yaw damper 1. Okay. All right. You do have an auto mode and a manual mode. Okay, so auto mode, the FAC is going to compute the Dutch roll damping, because the whole idea is to reduce that threat of a Dutch roll. And so in auto mode, it's gonna start computing that. It computes that damping and the engine failure compensation as well in the toga. Now you also have a manual mode. So when the autopilot's not engaged, okay, and then you have the ELAC is gonna sending to the FAC. It's going to be sending for the Dutch roll damping, engine failure compensation, yaw orders, and also for the turn coordination. So those are the things that would be functioning or be functions in manual mode. Now, what about the land mode? You have a land mode. When that's engaged, then you have the yaw order that's computed directly by the FMGCs. Okay, that's the next thing we're going to talk about in session 3, but just that's the connection. Here's land modes connected because it's computed directly by the FMGC. Okay. You also have a power loop. It's just the feedback in the power loop that's given by the transducer for the command side, and then you have another one for the monitor side. So it's just in order to operate that. The monitoring, you do have monitoring at power up, so just making sure everything's good. So it's going through its safety tests, and then of course you have your ELAC. Of course, beside you have your ELAC, your FMGC, and your aiders. Those inputs are always being monitored, constantly being monitored. Okay. Speed's important. Remember I mentioned about speed and how we're talking about aircraft energy and how, what's related to aircraft energy. When we're talking about current speed, we're talking about the acceleration rate as well, right? So here we're talking about the function of the FAC or FAC. We're talking about speed computation display. So we have that. And that's going to be on the PFD, okay, the primary functional display. And it's going to show also the speed limits, okay, to the FMGCs. Those are going to be sent there. So in normal operation, we have a FAC1 data. That's going to be displayed on the captain's PFD. And then we have the FAC2 data that's going to be showing up on the first officer's PFD. That's how that works. And then, of course, in flight, kind of a thing here you have is there's the flight and center of gravity. Okay, that was an added piece of information here for you. But FAC actually computates the weight of the aircraft. It's weight with the air data inertial reference system, your aiders, right? Like I've been mentioning, and also computes that with the FMGC and also with your CFCC parameters. Okay, your flap control computer. Okay, so that again with speed, weight along with the center of gravity, as it's able to calculate that. Okay, now, and that's in flight. If you have the case where the airplane's on the ground, the FAC is going to use the weight that's provided from the FMGC. Okay. So what about the flight envelope protection? Remember I mentioned alpha floor and said I might as well mention it now, right? So I did earlier with alpha floor. I've been mentioning about the aircraft energy, and then I defined wind shear for you so that we can talk about these things now. When we talk about the flight envelope, we want to make sure that we are keeping within certain parameters, that we have certain thresholds that we don't want to go past, and we will make sure within those thresholds. And so this has a lot to do with the performance of the aircraft, right? We have to have a certain speed at certain altitudes and certain wind conditions, et cetera, et cetera. And so we're getting these sensors to send data to the FAC, but it doesn't just send it to the FAC, it's also sending some to, possibly the ELAC. Okay, if you remember from flight controls, the ELAC is the elevator aileron computer. And so when we're talking about alpha floor detection and wind shear, for example, so we're talking about those two aspects, or threats, if you will, is wind shear is not a good thing. That's not a good condition for an aircraft flying. Your alpha floor, you have too much angle of attack. That's what we don't want. We do not want that. So it's going to be detecting as soon as there's a sign of those two conditions, which are your threats, then that kind of information can be computed by the FAC or the ELAC, and then that data is sent to the FMGC. Okay, so that combination there is just protecting against that increased angle of attack. That's what, again, putting together, that can be a problem with the wind. Okay, wind directions, etc. So obviously what it's doing is going to compare that to what it should be, right, what its marker is, and then, giving that warning. If it happens to go past that threshold, it's not within the limits, then a signal is going to be sent, and say, what's that going to affect? Like I teach in classes, I say, okay, if you have this, okay, what does that imply? If you have this condition, it implies, what action is going to happen. So in this case, when we're talking about alpha floor and wind shear, okay, which is part of flight envelope, we have, if it goes past the threshold or outside parameters, then what's going to happen is that we're going to have an engagement of auto throttle, okay, because we want to apply enough force here, enough thrust for the aircraft in that particular case. So if we have the aircraft in a clean configuration, then we have a compensation function that's not available for that wind shear. Okay, so just kind of a side note, remember we've got a normal configuration, we've got a clean aircraft is in clean configuration, then we're not going to have that function available, like compensation for the wind shear. So that's something that we're going to have Rick at some point talk about. It's great to have a pilot on board OA, Operation Aviation, because it really is a new perspective, and vice versa. Having a pilot understand from the aircraft maintenance technician's point of view, how is he looking at things, and you guys being put together, it really optimizes the safety of the aircraft because of those two perspectives, and just giving you, again, you guys are working on the plane, pilot's flying the plane, and his job and your job essentially is to just make sure everybody's safe. All right, so the ELAC and FAC, these two, okay, remember I said those are as far as alpha floor and your protection, or excuse me, your wind shear protection is computed by those two computers. What's going to trigger that? What is the magic number, the magic line there? If you have alpha protection condition, okay, and the side stick deflection at greater than 14 degrees, or you have a pitch angle that's greater than 25 degrees and the side stick deflection of greater than 14, okay, this is the condition, and the alpha floor is available. Okay, so those are the following cases where you're going to have the triggering of the alpha floor. Now, if you have a failure of any of the following, and I may have one of the two or those you might see on the test, but I just wanted you to bring your awareness, of combinations here of failures that can, cause essentially the loss of having a protection of the alpha floor. So with here, remember I mentioned the SFCCs, your slat flap control computers. You have your control computer 1 and the other one computer 2. So with the combination, if you have a failure of both the SFCC1 and FAC2, okay, so 1 and 2, but one's the SFCC, okay, that would be the 1, and then the FAC2, if those both are, they're failed, then you're not going to have that alpha floor protection. If you have the flip-flops, you have SFCC2 and FAC1 failure, that's also another cause of that loss of protection. The other part would be a dual ADERS failure, or you have the dual FMGC failure that would also just not have that protection anymore. So just giving you a heightened awareness of some possibilities here when you have that loss of protection. Now with the windshield warnings, because these are warnings, okay, this has to do with flaps, because remember I mentioned the SFCC, right? So slats and flaps come into play with all of this. Flight control surfaces having to do, we got wind coming, so there has to be, some kind of warning against this. So here we have windshield warnings function, and that's with the flaps at, at 1 or greater, okay, at low altitudes during takeoff and landing. So you have a message. These are different messages. You have one which is an oral way of a warning, but you also have a wind shear message that's going to show up on the PFD, and that's going to be in red. So when you have that warning that's active, then you're going to have the flight director pitch bars that are, that will command a pitch attitude in order to recover. Okay, so just letting you know that. Now the windshield warnings function, whether it's during takeoff or landing, you're going to have the warnings function when you have the aircraft in certain conditions. Number 1 is going to be during the approach. Okay, it's going to be from 1,300 feet AGL to 50 feet AGL, or between liftoff and 1,300 feet AGL. Okay. Now, what about the low energy? Remember, I said aircraft energy is important too. So, with here, you know, you have an energy awareness, and what it is, it's a software situation, software device that's going to give the crew a sound. If you there's low energy, remember I said earlier, it's going to say speed. It's going to sound speed, speed, speed. It's going to be aural. You know, and be able to hear it. It's an audio warning, and so it'll say speed, speed, speed. So if you have low altitudes, then you're going to have a constant monitoring of the aircraft's flight path and also the velocity. This is pertaining to, again, that low energy. All right. Okay, so obviously if we have low energy, what do we want to do? We want to increase power, right? So, you know, when the pilot's hearing that, he's going to need to apply some thrust because the plane is losing some power here. It needs to get up there again. So that's the action that needs to be taken by the pilot. Okay. So that's kind of giving you an idea with the wind chill warning. Now, that's what can show up when there is that situation with a wind shear. Now, how do you test the system? You know, how do you test the wind shear warning test, or wind shear warning system? There's a test for this, and what it's doing is checking. It's checking to make sure that the system will indeed display either visually, or it'll provide that audio warning of the wind shear when it's present. Okay, and that messages are there to indicate, you know, the loss of that. So that's all performed through the CFDS, okay, through the MCDUs. Okay, and you can do that on the MCDUs. There's a it's kind of the same what we've seen with other systems, but it's going to say system on their report test. So that's what it is, and you just run that test just to make sure that that system's working right. Okay, so for example, if you have your, you know, a test for 3 and 6 pages, okay, there's a -3 and -6 pages. When the predictive wind shear function is active, then you want to make sure of something. You want to make sure there's a certain message, okay, and that message is, and this is on the EWD, your engine warning display. You want to make sure that it says REAC WSDET. Okay, so REAC WS, okay, for wind shear, DET, okay, detection fault message. So I want to make the distinction between that, and there's another one that's called the wind shear wind shear DET fault. So you get the wind shear DET fault that could be there, but that's not the one that you need to make sure is there. It's the REAC wind shear, and then that's on the engine warning display. If you go to the status page, that's, you know, you want to make sure, again, same message should be there. Okay. All right, so I hope that gives you some idea what the wind shear detection function and the test that is run to make sure that those there is a warning, that it actually is, you know, providing that, you know, visually and also auditorily. Okay, so what about the flight envelope data on the primary functional display? Speed, okay, flight envelope, we're talking about speed, so a lot of different kinds of speed when we're talking about this, but we've got a speed scale, and you can see from the display, you know, it goes from the bottom to the top, you know, from low number to high number, okay, and you've got your Vmax at the top, you've got speed protection, you've got a green dot in the middle, because it's going to want to be going or achieving a certain level. So you'll see those speed scales. Okay, that's on the PFDs. All right. Okay, so for example, let's just take the speed protection. We want to make sure that the speed is where it needs to be. We don't want to have an overspeed. But there is a speed protection, okay, and there's a symbol that indicates the speed, you know, which the overspeed protection becomes active. So, you know, you've got that. All right, then you also have a speed, you have a speed trend. This is a yellow pointer that starts from the speed symbol. Okay, and you'll see that on the display. It's like almost like a little plunger type syringe looking thing, but it's in yellow. These things are very clear with their colors, so that you can identify them a lot easier. Your alpha max speed, that's the top of a red strip, okay, along the speed scale. That is what's defining that alpha max speed, and that's the speed that's corresponding to the max angle of attack that can be reached in the pitch normal law. If you remember from pitch or from flight controls, we were talking about normal and alternate law and direct law. Okay, so here we're just talking about pitch normal law, basically normal operation. And then of course these facts are they're computing the speed in the pitch normal law. You also have target airspeed. That's going to be in a magenta or a cyan color. It's kind of like a purple. Looks like a purplish red color. So you'll see that. That's your target airspeed. And it's at the bottom left-hand corner of that display. That's just the value computed by the FMGC in that managed speed control, or manually entered on the flight control unit. Okay, so if there's a number there, it's because it's out of the range. Okay, there's the speed scale, and then the target speed value is going to be shown there below or above that speed scale. Okay, then you also have a minimum selectable speed. That's, there's different little abbreviations for these different terms, but I'm not going to go into those. But just know that there's at the top of an amber strip along the speed scale, that's the minimum selectable speed, and of course it's computed by the by the facts. So speed scale, just wanted you to kind of get the idea of a speed scale and how the numbering goes, and the yellow indicator, and also the identification through color with that cyan magenta color for target airspeed. Okay, and then the top of a red and black strip along the speed scale, that's going to define your stall warning speed. Okay, stall warning speed is indicated with a VSW. Okay, so VSW is for stall warning speed. Okay, you've got a green dot. That's the engine out operating speed and clean configuration. That's shown in flight as the green dot. Then you have two amber dashes that show the predicted VFE. Okay, your VFE is your maximum flap extend speed, because we're dealing with flight envelope, we're talking about affecting the flight control surfaces. How fast are these things going, and as far as the movement. And so here there's amber dashes that are going to show that predicted speed of extension for the for the flaps. You also have slat retraction speed, so that's going to be shown with a green -S symbol for slat. Okay. There's also a V1. If you see the V1, that's called the decision speed, or identified by that, is the V1. And that's kind of in a cyan or kind of a purplish color. So you'll see that on there. Basically, the crew could enter the decision speed, whatever that is. And so if you have an indication that's out of range, that's going to show up on the upper part of that area. All right, so there's I mentioned about the wind shear warnings. If it's out of that range, you're going to have a warning that's sent. It's going to be audio and as well as visual on the display. So that's just one example of warnings. These warnings mostly are coming from the flight warning computer logics, but there's one. The one thing that's not is obviously the push button for the fact that's coming from the flight augmentation computer itself. So that kind of goes without saying, but But the different kinds of warnings, you've got warnings for, besides the wind shear, and I mentioned low energy warning, which you have the flight path angle as a function of it. You've got current speed and acceleration rate. So when I describe, hey, how is aircraft energy defined, at the level of that aircraft energy, it's a function of current speed, your flight path angle, and your acceleration rate. Okay, so if it goes below certain parameters, then thrust has to be applied, right? Remember I said if you have too much low energy, pilot's gotta input something to input that thrust. You're gonna have that audio sound, speed message is gonna trigger every so many seconds. So, and then you also have fact 1 or 2. So you could have a fault with one of the computers. If that happens, it's like a system issue because computer goes down. I mean, you got 2 of them, right? But if just one of them, if there's a fault with one of them, you have one of the computers, then the master caution light will come on, and you're going to have an audio sound, and so that's going to show. Then you're going to have that fault light show up in amber on the push button for the FAC. Whether it's a FAC 1 or whichever one is, has a fault. And then with the rudder travel limitation system, if you have a fault there, anything that's like system related, a system failure, the master caution light's going to come on. Okay, that's simple way to remember it. But so that's going to happen. All right, and some other things to be aware of. I know I mentioned system failure, master caution is going to come on, but and again, that could be the yaw damper system as well. However, let's just say you have one problem with one of the rudder trims, then the amber indication is going to show up on the display, but it's not, the master caution light is not going to come on in that case. It won't come on, and you don't have to reset anything when there's only a single fault. Okay, as far as 1 or 2, if one of them's out, then you don't need to do anything. There's no reset that's necessary. And that goes for that as well as the travel limitation. All right, and just kind of, I'll probably have, again, we're going to hopefully have the fortunate situation where, when we have our pilot available, he'll be able to tell you a little bit more about the flight phases and inhibitions that are there, and what sounds off, what lights come on, what aural warnings are sounded, that type of thing. When we have different failures, when we have things that are going outside of threshold, outside of those parameters, what all's happening. Okay, and this is again having to do with the flight envelope. So mentioning about low aircraft energy, your wind shear, okay, your rudder trim travel. Rudder travel limitation, as well as your rudder trim, your yaw damper systems, things like that, if there's something that's wrong there. Okay, all right, so that gives you a pretty good idea about the flight augmentation computers, and kind of what they're responsible for. And remember, most of the warnings are going to be coming from the flight warning computers, but again, the flight augmentation computer is really kind of the bodyguard, if you will, with having the protection of different aspects to the performance of the aircraft. So that's its job. Okay, so let's go ahead and go over some knowledge checks because it's time for some of these now. Okay, so what can we be tested here? Okay, just take notes because a lot of these you're going to see on the test. What are some functions of the flight augmentation computer? Okay, here's option A. Yaw damper, rudder travel limitation, rudder trim, and flight envelope protection. Or is it B? Okay, override protection, flight plan enhancement, rudder trim, and radio augmentation. Okay, it's the first one, right? Mentioned about how it's trying to protect from Dutch rolls, really trying to reduce that. The travel limitation on the rudder, to make sure it stays within limits. Your trim, right? And then everything I mentioned about flight envelope. Okay, so what are some of the things that the FAC computes? Okay, option A, aileron position, elevator position, and RPMs. Or rudder trim, characteristic speeds, and wind shear indication. Okay, it's going to be the latter. From which computers does the FAC receive data in order to calculate for flight envelope protection? Is it the first one, LGCIU, your ADARU, your FMGC, and your SFCC, or the ELAX, FADAX, and SEX? Okay, it's going to be the first answer. Okay, all of those different computers. Where are the two FACs located? Is it the left hand of the avionics bay or the right hand of the avionics bay? This would be aft, by the way. Okay, it's on the right hand side. Right hand. Threats to the flight envelope are the alpha floor and wind shear. Is that true or false? Okay, that's true. What engages the FAC in normal configuration? Is it A, is it the first answer, the FAC push button pushed in, or the rudder pedals? Yeah, it's the first one. Okay, what disengages the FAC? Pressing the FAC push button, or is it the computer fails? Okay, I think that's kind of obvious, but the computer fails. Okay, the FAC can still be engaged from the ground during the 30-second power-up test. Remember I said about the 30-second power-up test. Can it still be engaged from the ground during that time? Okay, false. It's not. It can't. It's like trying to boot up something and you're trying to work on Microsoft Word or something. Okay, when does the fault light remain extinguished even though there's a fault? Okay, is it when the yaw damper fails? Okay, and then I'm not talking about the system, I just said yaw damper. Or is it B, when there's temporary loss of the FAC? Okay, the answer is the first one. All right, resetting the FAC after a temporary power loss can only be done in flight. Is that true or false? I know I didn't quite mention that, but the answer is true. You can only reset it after a temporary power loss, in flight. All right, alpha floor detection. Okay, which the FAC detects, is important in relation to what kind of engagement? Okay, is it engine power engagement or auto throttle engagement? Okay, it's going to be B, right? Auto throttle engagement. Okay, computation of the weight and center of gravity is done by the FMGC. Is that true or false? Okay, that's false. It is done by the flight augmentation computer. It's done by the FAC. Okay, of the FAC warnings, which faults result in a master caution light illumination, a chime sound, and failure shows in amber on the displays? Okay, here are your choices. Okay, the first one, is it rudder trim system and or rudder trim limitation failure, or rudder trim system and or yaw damper system failures? Okay, it's the latter, right? I said any system failure. The other one about rudder trim limitation, it's either one or two. It's just a single, so the master caution light's not going to come on. But if it's a system issue, then that master caution light will come on. When does automatic reset of the FAC happen? Okay, is it A, one rudder trim limitation failure or one rudder trim failure? Or option B, you have one yaw damper failure or a single system failure? Okay, the answer is the first one. Okay, automatic reset happens when you have just your singles there. And that's just one example of one where you have an automatic reset. The AFS is a fail operative system. What does this mean? Okay, your two choices. It means that the right right after failure of a single system component, the plane can achieve a successful ILS approach, auto land, and a rollout? Or does it mean that right after failure, there's no significant change of attitude of the aircraft or the flight plan? Okay, the answer is the first one. Remember, I said there's going to be action of some sort, after a failure. That's why it's called operative. Okay, right? Okay, there's going to be more questions. I'm not going to go to every single one of them, so let me just kind of throw out one more to you. Name 2 component failures that will cause a loss of alpha floor protection. Okay, here are your 2 choices. Number 1, the combination. All right, so CFCC1 and CFCC2 failure. Okay, that's your slat flap control computers. Or is it from SFCC2 and FAC1 failure? Okay, it's from the latter. If you have SFCC2 and FAC1 failure, then you're going to have a loss of that protection of alpha floor. Okay, so that gives you an idea. Certainly there are more questions, but we can do a review so you can kind of really get this in your mind and take notes and whatnot. And certainly you can always reach out to us and email and if you get stuck on something. So not a problem. Okay, so this concludes our session 2, which was on the flight augmentation computers. And we have our final session for Autoflight system, which would be our final type of computer, which is the flight management and guidance computer. And that is the abbreviation which I've been using all to this point, your FMGCs. This is session 3 of Autoflight system for the Airbus A320 family. This is our final session for this particular topic, and we're going to look at different aspects here with the flight management and guidance computer, which is the title of this last session. And I want to do just a quick review of the FMGCs, and then we'll go into talking about the engagement push buttons, so we'll learn about that, as well as the different knobs. These are the control knobs on the control knobs that are part of the computer, and you have control knobs that are part of the FCU. Okay, and then we'll go into the warnings. We've got the priority logic testing, so it'll include the byte test as well, and then also the ILS approach. So we'll be talking about all of that. Okay, so flight management and guidance computer. Just kind of reiterate here, just remembering management and guidance, right? So these are the 2 parts to the FMGC is the guidance. This is having to do with flight plan and the control of the aircraft, using the navs. So guidance, we're talking about the navigation and the use of the inertial reference system, so your IRS, alignment through the MICDUs, okay, and then all your navigations, which you probably haven't covered yet, but navigation, with all your different devices there on the craft. Okay, and just remember, we have an FCU that we're going to be introducing here. So remember, FCU is a short-term interface between the crew and the MICDUs, and then you have between that and the FMGCs. And then you have the MICDUs, which are the long-term interface between the crew and the FMGCs. Okay, so we'll be talking about FCU here in a little bit. But just overview here, remember we got our displays, the primary functional displays, so your PFDs. There's 2 of those. And then you have your navigational displays, so there's 2 of those as well. Your MICDUs, okay, the ECAM, EWD, and your ECAM status pages. Okay, so, and then under flight guidance, when we're talking about guidance, we got your AP, your autopilot, okay, right, your flight director, which is FD, and then you have auto throttle functions, which is the ATHR, okay, designation. Okay, so we'll be looking at those different pieces and different parts. All right, so, and then the flight control unit, this is going to be including mode indications and you get different parameters with this. There's going to be a lot of things involving with the FCU as far as what it, what it's engaging, and so we'll get into that a little bit. Okay. All right. So, and of course, you guys already know where they're located. Remember, I mentioned that in session. In the previous sessions, we talked about it's on the 80 VU rack. Okay, for both of those computers. All right. Okay, so let's start with the engagement push buttons. Okay, what kind of buttons can we expect to see, here in this FCU? So here you've got different push buttons. You've got actually a total of 6 push buttons, and just kind of from left to right as you look at it dead on, you're going to see the localizer engagement push button, and then just continue on that horizontal line of view. The one next after is your auto thrust engagement push button, and then after that you have your expedite engagement push button. Now the expedite may or may not be there. It's an optional function, so just keep that in mind. Then you also have your APPR, your approach engagement push button. So those are your 4 buttons across there on the panel, and then on the FCU, and then you also have the autopilot 1 and 2. So autopilot 1 and 2 are located just above the auto thrust engagement push button. Okay, and when it's active, it's going to show 3 horizontal dashes above the abbreviation on the push button. So if you don't see it, it's not active. If you see those 3 buttons, and 3 lines that are green, then that means it's active. Okay, it's been activated. Okay, so let's start with the push buttons. Like I just mentioned right now, you've got 2, AP 1 and 2. So those are your 2 autopilot push buttons. And you can engage these after liftoff. Okay, you have to reach about 5 or so seconds after liftoff. And those can be actually, put into play by the pilot. So those get engaged. And of course, remember I mentioned that those 3 bars are going to show up in green once the engagement has occurred. All right, so you've got that, and then you've also have you've got the localizer. Okay, they got a localizer engagement push button, and usually this is going to be used when there's not a glide slope that's available. Okay, that's typically why that would be pressed in the on, which would put it into a loc mode. And so when that happens, that's going to be engaged, and you've got an arms, situation. When it's pressed off, and then you're going to have the localizer mode is disarmed, because otherwise it was armed, earlier. Also, besides disarmed, this is before capture, will be disarmed, but afterwards it will be disengaged. And so, in this particular case, you got the heading track mode that's going to be engaged on the heading track. Okay, because that's what it has to do with. So that's your localizer. Okay, and back to your AP. Okay, we have those 2. Those, again, pretty simple. If you see the bars on any of these, that means it's active. Okay, and then you also have your auto thrust. Can be interchanged with auto throttle, but that's what it is. And so you have this one, and if it's automatically engaged on the ground, it's automatically engaged when the takeoff is initiated with the thrust levers. Okay, so that'll kick in when that happens, and of course you press it off, it's going to disengage. And then there's the expedite, which may or may not be available or be there. The expedite mode is an EXPED, XPED mode. That can be engaged either when the plane is descending, or if there's a climb going on, that can actually be there. And that's just basically allowing a max climb or descent. Just kind of adds a little boost to it. And then of course your last one, as far as your engagement push button switches, you have the APPR. That's your approach, and that's going to actually, when that's depressed, then that's going to set off or put the mode into a land mode. Okay, so you're going to have that, and then how is that tied to anything else? Well, you're going to have the glide slope and loc modes armed for capture and tracking. And that's assuming that the ILS is available. All right. Or if, you know, or that you have an APP or nav final, you know, just in case the ILS is not available. So, you know, but just so you know, when that's depressed, that means you're going to have land mode, you know, active. And then, of course, if you have it pressed off, it's going to disengage, you know, become disarmed. There's certain parameters with a lot of these different buttons. So, you know, just kind of keep that in mind. It's more from a pilot standpoint, but there's certain thresholds where, you know, certain things are going to be inhibited, certain functions are going to be inhibited, and if it falls below or it has, you know, goes past a certain number of feet, like say radio altitude, if it goes past, then, you know, they'll say you won't be able to have a function of one, or the pilot won't be able to have a function of one of those. Okay, so that's what you have on the engagement push buttons. Okay, so I'll just kind of summarize what we have here on this. We have 2 autopilot engagement push buttons. We have 1 localizer mode button, 1 auto thrust button, and 1 expedite, and then 1 approach push engagement push button. Okay, so those are your buttons that you have available. Okay, and then what about, you know, what else do we have? We also have, you know, knobs. Okay, the knobs and switches. And so here with the knobs and switches, we have different ones. You know, we're going to rattle off here, but we'll start with the speed Mach control, because you're going to see that from left to right visually, you know, physically on the unit. So from left to right, the first thing that you're going to see on the left is going to be the speed Mach control button, and then to the right of that is going to be the control knob. It's a reference control knob for the speed Mach. So as far as speed Mach control, those are on the far left side. And so you have this, you've got, you know, the different kinds of function engagement that you'll have is the engagement of course, the APs and your FDs and your auto thrust. Okay, and the reference control knob for the speed Mach. Okay, all the knobs are going to be able to be either pushed in, pulled out, or be able to be turned. So let's just say in case of the speed Mach reference control knob, let's just suppose that we want to, you know, turn it. Then what that's going to do is just going to change the displayed speed that's on there. Okay, so if there was already a speed showing, then when the pilot actually turns that knob, obviously it's going to start changing that number, you know, that's displayed on that speed window, which by the way is right above those two, the button and the knob. The display window is right above it, and so you can see whether, you know, how that's changing when you turn the knob. So, you know, then the other option is you could push it in, and so when you do that, then there's going to be some dashes, and then you're going to see a light come on, and that's like a Mach dot light that's going to come on. If you pull it out, let's say you pull it out, then there's going to be a reference speed that's going to be displayed on the FCU. So it can be like a, you know, whatever selected is going to be displayed on the FCU. Okay, and in that case, the speed Mach dot light is going to be off. Okay, so that's for speed Mach control. That's number 1. Because then we have another thing we got to look at, and that'll be lateral control. The lateral control is the next button to the right of the reference control knob for speed Mach. So that's the next thing you're going to have is your heading track lateral control. So that's designated as LAT on the at the control knob. So that's LAT control knob, and it's, you know, may or may not be marked that, but that's what it is. You can be pushed or pulled. This one can also be turned. So like, remember I said knobs can be pushed, pulled, and turned. So you're going to see the letters LAT as the window. So that'll be the lat window next to or it'll be to the right of the heading, and of course all that to the right of the speed window. So that'll show up there. You get the lat window that's going to show a value in there when you have the heading or the track mode that's active, or there's already a preset that's done, and then you're going to see that. Okay. If you have it pulled, then you're going to have the heading or the track mode is going to engage with the reference that's shown on the FCU. Okay, and then of course turned, you have you can, it can also be turned. So, you have that. Of course, it's going to show, the effect of that. Okay, it's the same, basically the same function of what I mentioned with the speed mod control button and the knob. Okay, so the other thing that you have is altitude control. So, you get altitude control. There's, with the altitude selector knob here, you've got an outer and an inner knob. They're like almost on top of each other. So you've got the outer knob that there has two selectable positions. You got two choices. There's 100 feet, or the pilot does. You have 100 feet and 1,000 feet. And then you've got an inner knob that's going to set the altitude in the FCU altitude window with increments. And it just depends on the outer knob position, what that is. Okay, so this knob can be pushed or pulled and turned. Okay, so if it's turned, it's going to be changing by thousands or hundreds of feet. Okay, it depends on the outer knob selection, what that units of measure is going to be. Okay, so then you have that. And of course you can pull, you got pulling it, so you got a mode that's engaging. If you have a displayed altitude that's different from the present aircraft altitude. If not, then there's not going to be anything displayed. If you push in the knob, okay, the altitude selector knob. So when you push it in, then the CLB or DES mode, okay, there's your climb or descent. Same thing when I mentioned about, okay, when I talk about pulling, okay, climb, descent, ops. That mode is going to engage if you have a displayed altitude on the FCU, and that's going to be different from the present aircraft altitude, then that's going to show there. Okay, otherwise it won't. Okay, same thing. All right, so there's that, and then you also have the vertical speed flight path angle, which is your VSFPA, and that's a control knob. Same process. It can be push, pull, turn, and with here, if it's pulled, then obviously you're gonna have an engagement, there with a reference displayed on the FCU. The other thing you're gonna have too, besides that, you've got okay, so you've got the vertical speed flight path angle, okay, control knob. There's also a heading. There's a switching push button switch. So there's a heading vertical speed track FPA, and that push button's allowing selection of the heading and also your vertical speed or track and FPA modes. Okay, so just the extra thing you have there. There's different parameters. Follow the AMM, but it just depends on like what those parameters are as to what's actually going to be showing. What value is going to actually be showing up on the display. And you can see the pictures and give you an idea of how these things look, how they're laid out, and kind of the how it would show on there. Okay. Now we're going to look at a little bit on the ILS approach. Not going to go too much into it, but basically this is regarding the auto land or the land mode with the depression of the APPR push button switch on the FCU. So here, auto landing uses the land, flare, and rollout modes. That land mode is automatically engaged at 400 feet AGL. Okay, if that's when both you have the loc and your glide slope modes are engaged. And then to disengage that land mode, you have to do a go around, or the pilots have to do a go around, or if both the autopilots are disconnected. Okay, so that's how, but there's no action on the FCU that disengages that land mode. It's going to be with that, and again it goes into an automatic. So that's for the ILS approach. Now on warnings, there's different warnings on the Autoflight system. You're going to install, most of them are coming from the flight computer logics, the flight warning computer logics. So you have, for example, one instance would be if both flight directors fail. or if you have the FCU, fail. And the FCU fail meaning both, because it's like one, but it's split. And so you have that could go off. And then the other thing too is the AP is off, so your autopilot, and there's going to be a warning for that. So we're just going to go over those are the examples of some warnings. Some other things would be the auto land, so auto land, and then the auto thrust limited. Okay, that's another warning that could go off. And then so you have that, and you also have capacity change. So capacity change, that's on the landing. There's going to be a warning for that if it goes outside of the thresholds. There's also an altitude alert, okay, that's going to take in account differences in obviously the reference altitude, with the aircraft altitude. So, you have that warning as well. And then you also have the decision height warning. And those, pretty much giving you a helicopter's view on the different kinds of warnings. So let's kind of just look at this a little bit. On decision height, okay, this is one warning. Some of them have an aural warning, or this is going to be where you're actually hearing a voice that's saying, remember I said there was one that said speed, speed, speed. Okay, that actually gets said, but it's just a voice warning. It's audio, excuse me. So with this, you have decision height warning, and that's going to have that voice that I'm talking about, synthetic voice warning. If that decision height, is within or going outside of threshold, etc. And so this is all depending on the radio altitude, along with the decision height. So you're going to have one that's going to be 100 above. Okay, and what that means is that the call out 100 above is given when you have the radio height that falls to the selected DH plus 100 feet. That's where that 100 comes from. Okay, so it'll either be 100 above or minimum is the word. Okay, minimum. And those two are the warnings that can be, that are involving the decision height. Okay, so that's one. And then the other thing is altitude alert. So you're going to have an altitude alert that takes, again, the difference between the aircraft altitude and that reference altitude, that's selected on the FCU, whatever reference altitude was used. And that's going to have effect on that window. Okay, and that's going to show up on the the primary functional display, and that's going to trigger an audio, okay, or aural warning. That alert is going to be inhibited, okay, by the glide slope capture and canceled by the altitude knob. Okay, but just so you know, you have a warning there, when that happens. And of course, what this is going to do, in order to cancel that sound, you got to press the master warning switch. Okay, so that's altitude. Then you have also the capacity change. This has to do with landing capacity. So if you have a downgrade of landing capacity, then you're going to have a warning, go off as well as the messages on the status page. So, that's what you're going to have here. The other thing I wanted to mention is if you have a MICDO failure. Okay, so if you have, one of those fail, you're going to have, obviously the amber color comes on for the fail, word, and that'll be illuminated on the MICDO. Okay, now that's one of the ones where the warning is not coming from the flight warning computer or controlled by it. It's actually coming from the MICDO itself, the one that actually has a failure. Okay, and then there's also your auto land, and that's a red warning, and that's just going to tell the pilot that he has to do a go around. Remember I mentioned about ILS approach and the push button there, and just if we have certain conditions there, it's going to be in an auto land. That's going to say that pilot needs to do a go around or a manual landing. So that's what we have here. It's a red warning, and it can only be activated in the land mode. So land mode has to be activated, and then you have to have at least one autopilot engaged, okay, to do that. And there's different thresholds with that, but just to let you know, that's another warning. The auto thrust limited, this one here with the auto thrust is active, and the thrust levers are below the climb detent, then you're going to have a master caution light illuminate, and there's going to be a repetitive warning that's triggered, And it's going to continue every 5 seconds until those levers are put back into the detent. Okay, so there's that. Then you have the auto thrust off. So here, if you have the loss of the auto thrust, there's going to be a warning. Okay, and there's 2 cases of this, just like in some other ones, there's 2 cases. One is that you have a loss due to an action on an instinctive disconnect push button. Okay, or you have thrust levers setting on idle that's performed above 50 feet. So with those conditions, that's the first case where you have a loss of auto thrust, and then you're going to have a warning. The warning is going to, be temporary with this first one. And so the amber master caution light is going to come on, but it's not going to stay on. After so many seconds, it'll cut off. And same thing with the auto thrust off message. That's going to be an amber, but after a while, it's just going to go off. Okay. And then of course you have another one where it's not due to that action of an instinctive disconnect push button. So it's everything, it's everything else. Okay. So there's that. And then of course the FCU, of course if you have FCU fault, then you're going to have that master caution light, it's going to show. And then you're also going to have an auditory sound that's going to sound off. That information will be showing on status messages, or will be showing up on the status page. Okay, and then autopilot, you'll have a warning for this one. The autopilot loss, again, kind of similar to what I mentioned earlier about, the first condition. If you have the first condition where you're, have an action of taking over with a press button, then you also have one where it's any other reason. You're going to have number one. Let's say you take action on that takeover push button. Then there's going to be a red master warning light that's going to flash for so many seconds. Okay, and there's also going to be a red AP off message that's going to be shown, and that'll show for a little while. And then there's also an auditory sound. So there'll be sound there that will come on. Then flight directors, failure of both the flight directors, you're going to have a warning on that, and that's going to be a red FD flag that appears on the primary functional displays. Okay. So that's what you have there with the warnings. Okay. I just want to go a little bit on auto thrust and kind of just mention some things here with the auto thrust. Auto thrust, this is in relation to flight guidance, okay, on the FMGC. So with your auto thrust function, this is going to send a command to the FADEC. Because remember what I said about the whole thing on Autoflight system, it's also about sending signals to FADEC, okay, for engine control. And so here, this is exactly what the auto thrust is about. Because you have low aircraft energy, then we're going to have an automatic engagement of auto thrust. So here are the functions. You got auto thrust functions that are going to be obviously acquiring and holding a certain thrust, okay, and also a speed or a Mach number. The reduction of the thrust to idle during the descent and also during flare at the final approach, okay, is responsible for these different things, and also protection against your alpha floor. Okay, so that's what auto thrust does. If you recall alpha floor, that just means we have too much of an angle of attack, at certain phases of flight. So, that's something that, is important, obviously, to a pilot. So we've got a loop principle, and, what we mean by a loop principle on auto thrust is in order to get this function, okay, then you have to have a target that's computed by the FMGCs, okay, and that's chosen by the FCU. You have that being processed. So it's going to send that over to the FADEC. Okay, it's going to do that through your EIUs, your engine interface units. So that's kind of the loop principle, just how it's going as far as sending the signals and coming back. And then you have, of course, the engagement of it can be manual or automatic. Okay, on auto thrust engagement. Remember I said one of the engagement push buttons is your ATHR. Okay, that's your auto thrust. So you have that on the FCU, and that can be engaged again by pressing on it. Now you can also have an automatic engagement of the auto thrust function, and that's when the AP flight director is engaged in takeoff or your go around modes. Okay, also in flight. Okay, when you have an alpha floor that's detected by the computers, then you know that's going to certainly kick in, right? And of course, in disengagement, if you're going to disengage the auto thrust, that can be manual or automatic. The auto thrust is manually disconnected. You can do that by pressing the auto throttle instinctive disconnect switch, and that's going to be on the thrust lever itself, or by setting all thrust levers to the idle position. That would be another way, or through the dedicated FCU push button. Okay. And just so you know, if there's a major failure there, those auto thrust that auto thrust function is just going to automatically disconnect. So I just wanted to kind of share that with you regarding that, and just kind of going over a little bit about the levers themselves. Okay, so you have thrust levers, obviously. You've got a rear sector, there's a center section, and you have a forward section. So with these different sections or sectors, however you want to call them, they're delineated by the detents. Okay, it's pretty standard, right? And those, of course, can be moved in those different positions and have different, action based on those detents. So, the forward section, it's corresponding to an FLX takeoff thrust, or also a maximum continuous thrust after the engine failure. So let's say you have an engine failure. So that way there's control there. Toga, okay, corresponds to maximum, toga thrust. Okay, and you also have function logic here, obviously. So either engaged or disengaged. When it's engaged, it can be either active or not active. Okay. All right, so I kind of just wanted to mention that to you, about the auto thrust a little bit. The other thing with, I went over the warnings and, obviously on the auto thrust. So, I just wanted to cover some testing that can go on. Obviously, you're familiar with BITE. You always have the BITEs, with these systems. And so we have this with the Autoflight system. Okay, and so what we have is, this is a, when we mentioned about Autoflight system, it's a type 1, which just enables it to have a two-way communication with the centralized fault display interface unit, okay, your CFDIU. So you have that. And the other byte, okay, you've also got your FAC, FM, and FG byte. Okay, so it's going to be doing fault analysis. Typically it's being made, on each side, and, it's going to be memorizing, obviously, the results of, storing all this information, whatever it finds. You do have your MICDO byte, of course. It does the test on the processor, the memory display unit, etc. Your FCU has a byte. It's going to, compute the maintenance status there, and, send whatever information to the FGCMD. Okay, so you do definitely have that. You've got your main menu as far as the, seeing what's available as far as the information or reports. Functions of the system that you have in the menu mode is going to be your last leg report, previous leg report. This is typical stuff. Your troubleshooting data. You also have your land AFS test, your LRU identification, and you also have ground scan. So, last leg obviously is on the ground only. Again, on the ground, you got previous leg report as well. It's going to show, two types of faults. It's going to show the internal and external faults that appeared in the last 64 previous flights. So that's all stored in there, and you're able to see that, to view that. Okay. The other thing too that you'll have is the wind shear test. Remember I mentioned about wind shear, so that's important to be able to have that function going. So you have that, and then of course the troubleshooting data. What you're going to see on this page from the fault context recorded in there is the date. You got UTC and flight leg. You also have COM, MON, okay, your monitoring, and the CM. your snapshot data as well for Ws 1 through 5. Okay, and the way you're going to access this function, you can do it from the main menu, okay, or from the last leg report, previous leg report, by AFS test. You know, these are different options. You're going to be selecting from the troubleshooting data option. Okay, so from the main menu, on the troubleshooting data, you know, option, there's the FIDS that generates a page for selecting the byte that you want to look at. Okay, so depending on what you're working on, so that's how you can do that. And then you also have on the selecting that troubleshooting data option, the FIDS directly presents that context of the fault which is being displayed. Okay, and the computer which identified the failure. And then of course you have LRU ident that can be obtained with the, after the obviously after power up test is done. But you have this on ground only. It's going to show, get the part number of the FACS and also the part number for the FMGCs. Okay, it's also going to give the aircraft identification there. So, and then ground, your ground scan, you can get that from the MICDUs. Okay, and being able to see the, the pictures, going to see what it looks like when it shows it. There's different configurations depending on the aircraft as far as displays. So here again, it gives you an idea of how it shows up. Okay, so when you're looking at ground scan, you got ground report. It shows like present, failure scan, and your last leg report, previous leg on the main menu. So it's all in green. You can see that as well. Okay. All right, that concludes session 3. Let's go ahead and go through just a few more knowledge checks and then we'll call it. The two parts of the FMGC are the flight management and flight guidance. Is that true or false? It's true. All right, the FMGCs are controlled from what two components? Okay, option A is the MICDUs and the FCU, or option B, the MICDUs and the FAC. Okay, the answer is the first one, MICDUs and the FCU. All right, last question. Which gives the short-term interface between the crew and the FMGCs? Is it going to be FCU or the MICDUs? Okay, the answer is the FCU, Flight Control Unit. All right, that concludes this whole topic on autoflight systems for the Airbus A320. If you have any questions or want to go over, maybe you missed an answer to questions or a few questions, email us and we'll go ahead and take care of that for you. Look forward to having you in the other videos.